Hey students, this is lesson 132. In this lesson we're going to try and learn how to understand what the symbols are a little bit more for writing linear equations. And to do that we're going to do graph. I have skipped to develop and understand B. This is on page 8 in your packet. So go to page 8 and I'm going to do this one with you. So I think this one best represents what we're trying to learn here. So in sequences like the one just mentioned, it helps have information about what kind of relationship is being described. For example, if you know the relationship is linear, you can find the rule just from a few points. So we're going to discuss that here. So here we have a linear relationship. And it says, think about how many points you need to plot in order to draw a line for this relationship. What is the fewest number of points needed? Explain. Well, I hope you're thinking that you really only need 2 of them because it's a linear relationship. The slope is constant. So let's say I plot 0.13, that would be right here. And then I plot 0.21, that would be right here. Well, I now know that all the other points are going to be at that same slope. So I can plot a few more, or I could just take after I have those first 2 points plotted, I can just take my line and run it through those points at that slope, and I'm done. And you'll notice that the other points land right on that line because it's a straight line. All right, so there's my line. So fewest is 2 points. And that's because 2 points determine a line, and lines have constant slope. We know there's a constant slope on the linear equation. All right, now I'm going to use the graph to help me find a rule for this relationship. The slope is rise over run, so I'm just going to look at this. And another thing I know that going from left to right, this line is going down, so it's decreasing. That tells me that my slope is a negative number. So if I look at my rise over run, and my slope will go right there. That's the coefficient. So this is a 1, and this is actually a 2. And it's rise, so it's 2 divided by 1 is 2. But since it's a decreasing situation, I'm going to make that a negative 2. So I now know in my rule that y equals negative 2x. Now the other piece of information I can get from my graph is where it starts. In other words, when the input is 0, what is the output? And that's the constant term I need to add on. So right here is when the input is 0, I just look up there and find where it crosses the y-axis. We call that the y-intercept, and that number is 5, and it's a positive number, so I'm just going to add 5, and I have my rule. Now, not all linear rules are in the form y equals ax plus b, but if you can rearrange a rule into this form, you know that this graph will be a line. So here we have equation. It says graph the equation to show that it is a linear rule. Okay, so what I'm going to look for is just a couple of values I can take from this rule. So I need to do a little math here. I need some x and y values that I can graph. I made my table a little bigger just so I can do some computing here for y. So let's say x is 0. Maybe 0 is a nice number. So if I put in 0 for x, so then I get 2 times y, put that here, 2 times y is equal to 4 times 0 plus 5. So 4 times 0, that's just 0. I switch this over to here. Plus 5 is 5. And I'm just going to do a little mental math. I'm trying to figure out 2 times what number equals 5. And to figure that out, you can do a couple ways. You can either do 5 divided by 2, or just keep trying numbers until you get the right one, but it would be 2.5. So there's a point that's going to be on my graph. And from the last problem, we found that we just need 2 points. So I'm going to try and think of one other point that I can use here. Just pick some convenient x value, like maybe, I don't know, I'm going to try 2 for x. So 2 times y is equal to 4 times 2 plus 5. Again, I'm putting this value of 2 in for x right there. So 4 times 2 is 8 plus 5 is 13. So 2 times some number equals 13. Well, that's just 13 divided by 2, which is 6.5. So, all right, I have 2 points, 0, 2.5. That goes right there. And 2, 6.5. It's a little bit above here, but I think that's all right. And then I'm going to draw a line through those 2 points, because I know that 2 points determine a line, and that should be good for my equation. So there it is. Maybe off just a little bit. Okay. Now we're going to write a new rule using what we just learned from the last time for this problem. And our new rule is we need to know the slope, right? And our slope, if we have 2 points, we can get our slope just by subtracting the y-coordinates. 6.5 minus 2.5 is 4, so it's going up 4 for every 2. And remember that the constant difference in the y value is the rise, and the constant difference in the x value is the run. So I can do 4 divided by 2, which is 2. And so that's my 2x. And then I need the y-intercept for my constant term, and that's right here. That's where I'm starting up. Or you could do rise over run from those 2 points. So I would be looking at going up 4 over 2 like that to get this value of 2. All right, so explain how a graph of a linear relationship can help you guess the rule. So what we've just learned is that my constant term right there, so y equals ax plus b is my linear equation. My constant term, b, is the y-intercept. And my slope is just rise divided by run. My coefficient is rise divided by run from the graph. So on this problem, the equation is, there's a point there and a point there. My rise is 2, my run is 5. So my slope is 2 divided by 5. 2 divided by 5 equals 0.4. So 0.4x plus my y-intercept is right here, which is -3, or y equals 0.4x minus 3. And then the second question says, explain how the method of constant differences can help you guess the rule for a relationship. Okay, so the constant differences in this table as an example, and you can just copy down this table. 8 minus 7 is positive 1, 9 minus 8 is 1, so my constant difference in the y values is 1. So the constant difference in the y's is 1. The constant difference in the x is, they're going up by 2 every time. Y goes up by 1. Now, y-axis is going up and down, so it's the rise. And the x-axis is the run. So I can now find my slope by just doing rise divided by run, which is 1 divided by 2, or 0.5. And then if I want to find the, I know I'm multiplying my, so I now know this part of the equation, 0.5x. So I'm multiplying x by 0.5. So let's say I take 3 times 0.5. Well, 3 times 0.5 is 1.5. So now what would I have to add on that to get 7? And I can just do 7 minus 1.5, which is 5.5. And that is my y-intercept, or my constant term in my equation. All right, that's the end of the video. We'll talk about it in class. See you later.